Hello, everyone. So we're gonna start this new unit. So this unit will be about exponential functions and logarithmic functions. So let's start off with this warm up and find out what do we know about evaluating just exponential functions. So this shouldn't be too intimidating. So go ahead and pause the video and determine what are these values. So hopefully you're able to plug them in and substitute the values. So we get 2 raised to the x, right? In this case, we are told that x is 1, so it's going to be the same thing as saying 2 to the first exponent. So 2 to the will be our solution. So just 2. Okay, the next one, we're going to go ahead and see that the function remains the same, and we're substituting a 2, right, for our x. So now I got 2 to the second, which should give us 4. Okay. The next one, when we got 2 raised to the 0, that is equal to 1. Okay, that is a property. And the next one, we got this right here, 2 raised to a negative 1. Well, that right there, guys, is additionally another property, but it pretty much tells you that you are going to go ahead and get the reciprocal of the base. In this case, this is 2. So in reality, now I'm going to have 2 over 1. That will be the solution. So the takeaway from this warm-up is to remember our Algebra 2 skills, and it told us that if we have an a raised to a 0, that is a 1, okay? So any number raised to a 0 is 1, and the next thing we need to know is when a is raised to a negative 1, that is 1 over a. So make sure you write this on your notes in case you did not remember, okay? Alrighty, looking ahead, the only thing I need to change from here is that this right here is going to be a Google form. I'll post it on the chat. I'll post it on Teams, and this will be due on Thursday. Okay. Other than that, everything should still be back on schedule. Okay. Alrighty, so this is just an introductory lesson. So we're going to go ahead and learn about the characteristics of exponential functions, such as are they exponential growth or decay, boundedness, symmetry, and asymptotes. Okay. Alrighty, same expectations for class. Okay, cool. So this is a new unit. So new unit, new me. So what I want you to know is that I am open to feedback. And I do also want you to self-reflect on how you've been studying or how you've been taking notes or how much effort you've been putting in class, along with giving me some feedback on what helps you learn better. So I have an idea of what some of you guys told me at the beginning of the year, but as you guys can see, this was a little bit different than what we all imagined. So I'm still open to feedback. So on today's homework, there's going to be 2 additional questions, and I encourage you to give them a try. So one, self-reflect, and second one would be about giving feedback just in general. All right, let's begin. So ideally, there is 2 types of exponential functions, and we can determine them, we can categorize them as exponential growth and exponential decay. Okay, so pretty much the parent function, okay, the parent function will look like this: a constant times a base that's raised to an exponent. So go ahead and pause the video, write these notes. Okay. Alrighty, so pretty much when the base is greater than 1, so when 2 to the x, 3 to the x, so forth, a number bigger than 1 is raised to an exponent, raised to a variable, it will look like this. So it will look something, just ignore that it won't be to scale, but it will look something like this. Okay, something that is writing. I'm just trying to make a solid line, not saying that it's actually going like that, just making it solid. Okay, the same thing goes for an exponential decay. So you can see that from the left, it's pretty much decreasing, 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 and it will decrease until it gets really, really close to the x-axis, but it will not touch it. For that reason is that there is horizontal asymptotes on y equals 0 for both of these. So pretty much you have something like this, completely horizontal, and all of a sudden, for exponential growth, it goes up. And for exponential decay, it goes ahead and decreases. Okay. All right, so both of these will be bounded because there's a horizontal asymptote at the y equals 0, at the x-axis. Are they symmetrical? So hopefully you're able to see, hey, my left does not equal my right, so these are not symmetrical. Okay. Alrighty, so what I want you to think about this, like whenever I think about an exponential function, I always think of loteria for some reason. And what I want you to know is like, in this card, there's a card called El Mundo, and that's how my students remembered it last year, and they were just thinking about this guy. So they have the left hand, right, for exponential growth. They have the left hand that's going to be close to the x-axis, right, and then it explodes up with their right hand. So they look something like this, right? I'm trying to do something like that. You know, same thing El Mundo guy is doing. You know. So when I talk about end behavior and stuff like that, you just think about your fingertips. Which way are they pointing? So this guy's fingertips are pretty much going up, and his fingertips are pretty much going all the way to the left. So just assume his hand was completely horizontal. So that's a nice little trick to think. So based on what you know from decay, remember decay is when our base is less than 1, but greater than 0. And our growth is when our b is greater than 1. Okay, so identify what are these functions doing. Are they exponential growth or are they exponential decay? So pause the video, give those a try. Okay, alrighty, so we have here that our base, right, our base is 5, so this much must be an exponential growth, something like this, right? This one right here, our base is a fraction that is less than 1, positive fraction less than 1, so this one will be a decay. Okay, and that will look like something like that, right? The next one is 1 over e. What the heck is e? Well, remember, e is also a value. E is an irrational number, so it's going to be like a number, so 2.71, so forth, right? Just like pi that we have in the next example, 3.14, right? They just continue. So 1 divided by e, 1 divided by 2-ish, will go ahead and be exponential decay. And if I have 3.14 ... raised to an exponent, that is exponential growth. So just by looking at the base and raised to an exponent, we can tell a lot of information. Okay. Alrighty, so let's go ahead and graph it. I know some of us are still struggling with graphing, so I encourage you to try desmos.com if you do need help graphing, but keep in mind you cannot use that on the exam. But overall, it's not bad stuff. Let's go ahead and try some graphing. So let me go ahead and hide these panels. And let me hide this panel. Okay, now I got more space. Alrighty, so let's go ahead and give this a try. Easiest way to do it is just make an XY table. Okay, from our XY table, we're gonna go ahead and pick some random values. I'm gonna put -1, 0, 1, and 2. And from here, we go ahead and substitute just what we did on Arduino. So let's go ahead and evaluate these. So 2 raised to -1, remember that's the reciprocal. So it's gonna be 1 over 2. So remember your function, your numerator drops to the denominator and denominator went up to the numerator. Okay, how about when 2 is raised to the 0? Well, that's a property as well. 2 raised to the 0 means 1. And the next one, 2 raised to the 1 is just 2. And 2 raised to the 2 is 4. So we have these points, -1 and 1/2. The next point we have is 0 and 1. The next point I have is 1 and 2. And last but not least, I got 2 and 4. Okay, so let's go ahead and plot these points. So -1's right here, right? -1 right here, and 1/2 is right over here. The next one I got is 0 and 1. The next one is 1 and 2. And last but not least, my next point is 2 to the right and 4 up, like so. So I got something like this, and I'll draw it in red. I got this graph, and I know because of this right here, the base is 2, I know this is an exponential growth. So it pretty much looks like it, right? Based on our points, it looks very close to the x-axis. Okay, when it was at 0, it's at 1. When it's at x equals 1, it is at my base, and so forth. So like that. So we have some graph like so. Okay, so it looks like pretty much like the parent function of our exponential function. So this right here, guys, when we're talking about end behavior, we're gonna go ahead and look at these fingertips, right? At these arrows right here of what the function is talking about, right? So this right here limits an end behavior, guys. It's not gonna leave anywhere. We're gonna continue seeing this throughout the year. So let's go ahead and remember what it means. As x goes to negative infinity. So as x goes to negative infinity, pretty much telling us as x's go to the left. What are our y's doing? Well, let's look at it. As x goes to the left, so as x goes to negative infinity, my y's are getting really, really, really close to this x-axis, right? It's getting super close. And keep in mind, we just talked about it having a horizontal asymptote at y equals 0. So the lowest it can go is 0. So this right here is y equals 0. We can probably see that it'll get super, super close. If you're referring back to the El Mundo, you can see that your left hand would be completely horizontal, right? All right, last but not least, as x goes to positive infinity, what are my y's doing? Well, let me get my little laser. As x's go to the right, as x's go all the way to right, so your right hand, right? What are the y's doing? What is your hand pointing? Well, keep in mind my y is going all the way up, so we can assume that eventually it will reach positive infinity, right? So as x went to the right, my y's went up to positive infinity. So that's what we're talking about. What are the little arrows pointing to? What are they telling us? Okay. So before we start plotting points, guys, before I let you try this on your own, I want to determine what is this? Is this exponential growth or exponential decay? So remember, we look at that based on the base, right? Based on the base. So this right here, my base is less than 1, but greater than 0. So therefore, this has to be a decay, right? Okay. So from here, now you can go ahead and try some values. So let's go ahead and do the same ones, -1, 0, 1, and 2. And go ahead and try these on your own, guys. So go ahead and give these a try. Okay, so from here, if I go ahead and put 1/2 raised to the -1, remember that's a reciprocal, it'll go ahead and make the denominator go to the top and the top numerator go to the denominator. So this should be left me with 2/1, which we know is just 2. The next one is 1/2 raised to the 0. That is the same thing as saying 1, right? Any number to the 0 is 1. Last but not least, this is 1/2 raised to the 1. That stays the same, 1/2. Last but not least, I got 2 raised to the 2. 1/2 raised to the 2, and that looks super messy. 1/2 raised to the 2. That's the same thing as saying 1/2 times 1/2, which is the same thing as saying 1/4. Okay, so I have all of these right here, all of these values. So all these points, so -1 and 2 is a point, 0 and 1, 1 and 1/2, and last but not least, 2 and 1/4. And I kind of have an idea of how a decay looks like, right? It's going to look something like this on my XY chart. Okay, so let's go ahead and plot these points. So at -1, I am at a height of 2. At 0, I'm at a height of 1. At 1, I'm at a half. At 1, I'm at 1/2. And at 2 to the right, I'm at 1/4. So I'm just guesstimating, right? So this right here is starting to give its shape like so. So I know it's gonna go ahead and go really close to the can't get it, really close to the x-axis. And as I'm going to the left, as x go to negative infinity, it's going to go ahead and go up. So I got something like so. Sorry guys, it looks very, very messy. Okay. Alrighty, so let's go ahead and talk about its end behavior. Keep in mind, we have a horizontal asymptote on all these exponential functions. Okay, so y equals 0 is a horizontal asymptote. Okay, and keep in mind, if you were to have different transformations on this, the transformations would also be applied to our horizontal asymptote. in case you can't really see it on a different exponential function that has been transformed, right? Okay, so from here, let's go ahead and answer this first question. As x goes to negative infinity, so which direction is that? Negative infinity. As x goes to negative infinity, that means as x goes to the left. As x goes to the left, we're talking about this one right here. So now my El Mundo is now flipped. Now I'm carrying it this way. So I can see that my left hand, my y's are going up. So it's going to be y will approach up, 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 so positive infinity. So this is positive infinity. So as x went to negative infinity, my y's went to positive infinity. Okay, how about this one? When x goes to positive infinity, so that's as x goes to the right, so as x goes to positive infinity, what is my y's doing? So as x goes to the right, my y's are going to the asymptote, right? They're going down, 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 down to the horizontal, which is on my x-axis, my horizontal asymptote. So that would be 0. Okay. So these might be a little tough since we haven't seen this in a while, but hopefully it's not that bad seeing them again. Okay, something that will not go from precalculus is being able to identify transformations. So some will probably have all these and some won't, but it's good to know what each one does. So my A's, if they're positive, there's a vertical stretch. If it's a fraction that is a positive fraction less than 1, we can go ahead and see that's a compression. Horizontals here are affected by my C. And if they are bigger than 1, they compress, and if they are between 0 and 1, they stretch. So pretty much opposite of what we're thinking, right? Counterintuitive of what we're thinking. Usually we think, oh, a 2 will probably stretch it, but in this case, it will actually compress it, according to this. Normally, the horizontal shift and the vertical shift don't affect as much. Horizontal still is counterintuitive. If I go ahead and subtract a value, so if something is negative, it moves to the right. If something is positive, it moves to the left. So a little still counterintuitive, but the K does not lie to you. If it's negative, it'll go down. If it's positive, it'll go up. Okay. So these are from our Unit 2 and Unit 1 transformations. So, and we will continue to see them Unit 4 when we talk about trigs and stuff. Awesome. Alrighty, so let's go ahead and identify these transformations. The first thing I want you to tell me, is it a decay? Is it a growth? Exponential decay or exponential growth? Okay, so go ahead and use this little template, and you can use your notes from the previous slide to let me know. Okie dokie. Okay, so we have the following. We have this right here. The 3 was our base, right? Our base, and our base was greater than 1. So this is going to be a growth, right? It's going to be an exponential growth. So the next thing we're going to go ahead and notice is this 2 right here. This 2 right here is a vertical stretch by a factor of 2. Okay. So remember, if there is an a value in front of your function and it's bigger than 1, it's going to stretch it vertically. If it's a fraction, then it's going to compress it vertically. Okay, this minus 5 right here, this minus 5, this is associated to our h. Okay, so that's the one that lies to me. So I see a negative 5. In my head, I'm thinking negative, it's going to go left, but it doesn't. It actually goes to the right 5 units. Okay, the last but not least is my plus 4. This plus 4 is associated with my k, and my k does not lie to me. So if it's positive, it goes up. If it's negative, it goes down. So 4 units up. Okay. I did have a couple concerns on what does C do. Well, keep in mind C is my horizontal compressions, like so. But if they equal 1, guys, it stays the same. So in this one right here, I didn't have any numbers, so it was just 1, or there was nothing I could factor from both, so it stayed the same. So no horizontal compressions, no horizontal stretch. So you could either say that, no horizontal stretch, no horizontal compressions, or you could just not state anything on that because it's a 1. That is all that I have for us. The homework can be found in this link right here. And they're not that bad. You go ahead and see a function, and you go ahead and state, oh, what is the end behavior that we're looking for. Okay, so on Thursday, this will be due. Keep in mind I added these right here. So just to go ahead and reflect on how you are treating your Unit 2 knowledge, Unit 1 knowledge. Is that working for you? Is there something we need to come up as a plan? And then secondly, the question is, what recommendations or suggestions do you have? So just a little self-reflection, right? Okay, that is all that I have for us, guys. As always, it's been a pleasure, and thank you.